I would. Can you 2 more minutes? Oh yeah. Sorry. Yeah, if anyone has any questions, pop them in the chat as we're going along, or we'll have about 5 minutes at the end for questions. So Gerardo, whenever you're ready to start.
Okay, thank you, Jenny. So you can hear me and you can see the slides, right?
They're kind of at the start of the talk, Gerardo, so you might need to forward them a bit.
It's not showing baseline and internet submission?
I'll forward it for you. You start talking. I'll find it for you.
No, I think it's in the correct slide. Okay, thank you, everybody. My name is Gerardo Roa. I'm postdoc working on the Cadenza project, and we'll go through the baseline and go in an overview and try to present what were our internal submissions. Okay, so as was presented by Trevor before, the baseline in task 1 was basically had 2 stages. So we have the enhancement and the evaluation. And the evaluation stage basically is a fixed stage where we ran the evaluation for all the entrants, so the participant. And if we do assume to the evaluation, so we received the 8 BDPO left and right BDPO, and using the reference signals, we compute the Hacky score. And the remix went to the listener panel, but we also scored the Hacky for the remix, because in that way we can correlate the Hacky with the listener panel. So basically, because the samples you process for computing the BDPO Hacky weren't the same as you process for the remix. One of the reasons of these different samples was, well, selecting randomly, but also we needed to select properly the samples, as the BDPO can take a silent segment, for example, a segment where there's no bass or no vocals, that will crash Hacky as is not expecting a silent segment. And in the enhancement, as you all presented before, so we have at the mixing stages that we applied then the amplification. That was one part of the submission, but the same BDPO, you can apply different remixing techniques and apply the amplification so we can score it. So for the evaluation, as just this is a way to try what we did technically. So we took the music, the WAV signal from the MuseDV18, the segment corresponding to when selected from the submission, the corresponding segment that was shared as a flag signal. We applied a flag to WAV, the compressor, and having the both signals in WAV and 32 bits, we scored the Hacky. So why we work with the flag? As the 4 previous presentation can testify, so the submission package they had to share with that was about 20 gigabytes, and that was with the compressed signals. So we managed to reduce the size of the package just using the flag by more than half. Otherwise, they would we wouldn't need it to submit 50 gigabytes to us, which in some cases will be probably impossible or very difficult. So moving to the enhancement stage. So as I said before, we have the mixing and a remixing stage. So in the mixing, basically what you all did was take the WAV signal from the MUSE-DB18 dataset. We applied some audio source separation, the MOOCs, open and mix, splitter, whatever. And we produced the 4 BDBO signals. In our case, so as in the baseline, we applied the hybrid demux, which was the baseline 1, and open and mix, which was the baseline 2. And then in the baseline and most of the systems, we had 2 paths, as was shown before. So we saved the PDBOs by applying the NALR to each vocal PDBO signals, then compressing to FLAG and submitting this FLAG. I'm showing 4, but we're not, all the entrants know that we're basically 8 because the submission was each left and right BDBO, so otherwise, in other words, 8 signals, and a remix signal that we add in some way the 8 BDBOs, produce a stereo wave, and apply the NRL, then the compressor, and submit, and finally submitting 9 signals, 8 BDBO and 1 remix, a stereo remix. In our case, as a Cadenza submission, we focus more in exploring different post-processing for the remix signal. So why we did that? Because we were focused more on producing more signal for the listener panel to try to better learn what are people with different hearing prefer in music. So we can make many assumptions, but we needed to have this feedback from them. So the submission were based on the hybrid demux. So the demixing part was basically using the MOOCs. And we try to, we process in 2 ways the signals. So one submission, one system was focused on trying to unbias the NLR. I'm gonna go in more detail later. And another approach was to apply some mid-side equalization. Yeah, for the unbiased, or what we call music NALR. So NARAL, part of the process, they have some bias that basically apply a roll-off to low frequencies. So in this figure, the red lines are the NAR filter. So as you can see, so frequency below 2 kilohertz are attenuate. So what our intuition was music, the bass or the low frequency components are very important for the enjoyment of the music. So for me personally, it's very important. So exploring different values of for changing the bias. So we try to make it penalize less penalization to the lower frequencies. So you can see in this green dotted line that we kept over 2 kilohertz the same bias, but below we remove that penalization that the NLR has. This basically modify the system just by changing the hearing aid. Instead of using the normal NLR, we use the music NLR. So the baseline, this is how NALR applies. So in one case, was very loud. So I don't know if you probably heard that, but you can probably you can identify that it's very treble. There's no bass or low frequency components. So we try to, with the music NALR, transform. Again, it's very loud. As you probably can hear, this sounds more with more low frequency part. There's a bass. Personally, thinks sounds more pleasant, but that's my perception, and that was not shared by the listener panel. As you can see, compared with the baseline, well, Haki have a reduction in Haki is not unexpected, as we are deviating from the reference, which is an alert signal, and we are modifying alert. So obviously, we will have a reduction of a Haki score, but we were hoping a better that will improve the perception of the quality. And in fact, we have a lower score compared with the baseline. Trying to find how this was. So basically, yeah, as Trevor said in the chat, we were wrong, and it's not all about the past as we were expecting. So you can see people found, obviously, in the frequency balance, as Jenny said before, closer to between 0 and 50 is more bassy. So obviously it was found more bassy. So, but that bass, it seems, was perceived more as a distortion rather than an improvement to the music. We may need more analysis, probably adding the bass. It helps, but not leaving all the bass. So more increasing the bias probably will be help, but this is part of the future research. Then we explore working with the mid-side equalization. So for those who are not familiarized with mid-size, that is basically an alternative to channel signal representation, rather than have a left and right signal. Here they try to separate the components that are in the middle, they are common in the left and right, from the components that are only in the, or they're separated. So the mid part is constructed by just adding the left and right, which making the signal mono. And the side is the difference between both. So in that sense, you can start working on, for example, in the mid side is very common that it is find the vocals, and one can just increase the vocals by increasing the mid side, the levels of the mid side, the mid component of the mid side, and then adding together again. But what we did was try to make the music to increase the vocals by increasing the side component, that trying to make it more wide. For that, we took the sides, the side, and I apply band filter a band filter, so between 2.5 and 5 kilohertz, and we increase the levels in that part in 3 dB. That results in a roll-off in the lower and higher frequencies of the side component, because we just kept that segment. No, it's more, yeah. So that after, well, in the process, we have the we generated the remix signal, the WAP signals. Then we apply the mid-side equalization, and but in this case we use the normal NALR and not the music NALR. So again, so now I'm gonna. That is the baseline. So with the mid-side equalization, I hope you were able to find the difference, or hear the differences between both. Well, in general, it was much shorter than expected. In general, the baseline was, as you already noticed, it had the highest Haki and got a very good audio quality score. We don't have the audio quality score for the open and mix because that system wasn't included in the listener panel, but basically wasn't included, so we could include more system from the entrance rather than this baseline. So the mid-side equalization had the lower Haki. That is also very expected, as we are deviating from a lot from the reference for Haki, but we got a very high audio quality as well. So that's show that it's a very that can be a promising way to go. And the music NALR, well, it wasn't what we expected. It had a reasonable audio quality score, but it wasn't we thought, well, with the bass, it's not that important as we thought. Yeah, thank you.
So we can take any questions. If anyone's got any questions.
There's one in the chat, Jenny.
Is there? Oh, sorry. Mid-side EQ audio sample appeared distorted. Perhaps the distortion is a Teams issue. That was from Steve Armstrong. So I think
yes. So I believe one part was from Team, but it sounds different. So because we did the roll-off in the low and high frequencies in the side component, probably if you retain some part of the side component that we remove, it will sound a little bit better. But one of the problems you can find with the mid-size is when you start looking the best options for the equalization or the mastering the mix is very by ear, and trying to find is very difficult to find, or was difficult to me at least, to find an very good overall option. And in this case, I try to be as broad as possible, so all the system had the same-ish result.
Do you have any more?
I'd ask a question if you don't mind, Jenny. Is that okay?
Yeah, go.
Yeah, I do think the increase in the bass and not being preferred is quite interesting. And I wondered whether that was to do with taking up the sort of dynamic range of what people could listen to in some way, and maybe increasing the bass might have led to some distortion in some cases. Did you have? You may not have had time. This has all been done hurried. Have you had time to look across how it varies from music to music?
No, I didn't have the time. So I'm curious to see between samples, how it behaves, but also how was the response between different hearing loss, levels of hearing loss. So probably in severe or moderate, they have a different perception of how this keeping the bass help them or ruin the music for them. But yes, it's something we need to do now.